Hello, everybody, and welcome back to the Python Primer for Student Researchers. We're going to be talking today a little bit about data types and how Python processes information. So I'm going to go ahead and start a new notebook. Again, I'm running Jupyter Notebooks using the Anaconda Navigator. And if you need some help installing that, just pop back a few videos. I'll show you how to do that. So I'm going to go ahead and click on New, hit Python 3. And that's going to give me a new window. So the three data types we're going to be focusing on today are strings, integers, and floats. Those are the primary ones that we're going to be using throughout the course. There is a fourth data type called a Boolean, which I'll get to in a minute, that actually helps with logical structures in your coding. But in terms of storing data, you pretty much have those three first data types. So a string is any sequence of characters that is surrounded by quotation marks. So if I print that out, it's just going to print that to the screen. Hello, everybody. So that's my string. Now, a string, the way that Python stores this is it's a list, a series of characters. So, for example, if I print out my string and take the 0th index, or the very first character, that's just going to print H. I could also print out a sequence of characters, like the first 4 or 5 of those, and that's going to give me the first word. So a string is just a special kind of list that has access to all of that information. And I bring this up because when we start reading files later, Python is going to interpret everything that comes in as a string, and we're going to have to access different pieces of it to parse out where our data is in the file. And so we're going to be accessing different aspects of that. So you can also use strings come with some built-in functions. So for example, if I want to split this string on white space, I just leave that empty, and that creates an array that has 2 words in it. Hello, everyone. And then I can access those independently. If I then decide to just access the first element of that, there it is, just hello right there. And the second element would be right here with index of 1. So again, that's going to become important when we start parsing data, because all of this data is going to be coming in as strings. Once we start to parse this data, we want to transfer it into numbers so that we can do calculations. So for example, in Python, let's say that I get an input value from a file or from the user. Usually Python is going to interpret that as a string. So this is, because it's in quotations, this input value, while it looks like the number 2, Python is interpreting it as a string, a character that's written on the screen as 2. So if I print this value, it's going to look like a number, but if I were to, say, put another value, if I were to take this and print 3 times that, for example, it gives me 222, which is not 3 times 2. And that's because Python is interpreting input value as a string, the character 2, and then it's printing that out 3 times. So in order for us to actually do some calculations with this, we need to do something called a cast. So we need to cast the string input value as a number that we can use. So say a float or an integer. So let's go ahead and do that. What I'm going to do is I'm going to redefine my input as a integer of my input value. And when I do that, if I say print the input value number, now that I've converted it into a number, it still looks like it's a 2, right? Just like it did up above. But if I now say 3 times that value, I get 6, which is what we expect. So this is called casting, and this is turning what we had put in as a string value in as an integer. There's another type of casting that you can do called a float, and that turns something into a floating point number or a decimal number that has that is not just an integer. And in this case, you'll see that change to 6.0 because that's a floating point number. But again, it does that cast there, that casts those into different values. Most of the time, we're going to be using floating point values, these decimal values. And just to give you an idea of what those look like, if I say have a value 100.5, that's a way of writing a floating point number, I can also write it in scientific notation. So I could write 1.005 e to the 2. So that's how we do scientific notation. We say to the exponent of 2, that's the same as saying 10 to the second power. And then if I print those out, you're going to see that they are identical as far as the computer is concerned. So they're both 100.5 floating point numbers. It's just that sometimes it's easier for us, especially if you're dealing with very small or very large numbers, to go ahead and do that. And again, if you were to give these things as strings, those are going to look different. And I'm not going to be able to do calculations with those. In fact, what I would have to do is I would have to cast those as floating point values by using the float function like that. Whoops, need to put in my last parentheses. And again, those go back to numbers that I can do calculations with. Okay, so that's our strings, that's our integers, that's our floating point values. The last thing I want to talk about is something called a Boolean. And a Boolean is a logical value that can only have two states, true or false. And this is handy for doing logical calculations if you want to check to see if a particular statement is true or false. So for example, anytime we compare two numbers, if we say this is larger than that, the result is going to be a Boolean, either true or false. And the way that we use a Boolean is I can just type in a variable name. This can be anything you want. This is my Boolean variable, and I'm just going to call that true, no quotation marks. Now I have set the variable Boolean variable to a value of true. And then if I print that value, oops, need to make sure my cases look good. If I print that value, then it's just going to list true. And it looks like a string, but it is a string as far as the computer is interpreting for you, but it's basically telling the computer that the value of that is true. And this is handy if I want to use conditional statements. So for example, I can say if Boolean value colon. So that's an if statement that's checking to see if Boolean value is true. And I can say print this is true. And I'm going to put that in quotes. And if I do that, whoops, Boolean value, it's not defined. Boolean variable, my apologies. Boolean variable, there we go. Okay, so that's happened here is because I have Boolean variable set to true here, down here it prints this is true because Boolean variable is true. If I change this to false and re-execute it, then I get false and nothing is printed when I execute that screen. Okay, so that's what we've got for logical statements. Those are the 4 data types we're going to be using: strings, integers, floating points, and Boolean variables. And up next, we are going to be talking about how we analyze data using vectors and matrices in numerical Python. So we'll see you over there.